In this first video for grade 10 Euclidean geometry, we're going to revise the grade 8 and 9 theorems. Euclidean geometry is a very specific chapter. Everything that you do should be based on facts, and these facts are called theorems. Every time you use a theorem, there is a specific accepted reason you need to supply. In this video, we're going to revise the grade 8 and 9 theorems. Let's have a look at the theorems you know about lines and angles. The first two theorems have to do with angles that come together at a specific point. In our first theorem, we have two angles that come together at point B, and they are on a straight line. And we know that these angles add up to get 180 degrees. So I can say angle B1 plus angle B2 is 180 degrees. And my reason for that is angles on a straight line. Next up, we have three angles coming together at a specific point and going right around. And then we know that they add up to 360 degrees. So A plus B plus C is 360 degrees. And my reason for this is angles around a point. I quickly want to stand still at how to write down the name of an angle. So in our first example, we had point B and angle 1 and 2. So we wrote down angle 1 at point B or angle 2 at point B. In the second sketch, there's no specific name for the point where the angles come together, but each angle already has a name, and that is indicated by a small letter instead of the point, which is a capital letter. So in this case, we could simply write A, B, and C for the angles. Or a third option, if we look at the picture at the top, there we have point B right in the middle, but none of the angles have a number. So if I want to, for example, name this angle, I need to name it by saying how it was formed. So it's formed A to B to C, so I can write that as angle ABC, or ABC indicating the angle is at B. Our next theorem forms when we have two straight lines intersecting. At that point of intersection, the two vertically opposite angles are the same size. So in this case, I can say that angle A4 is equal to angle A2 and also angle A1 equal to angle A3. My reason for that, vertically opposite angles. Our next group of theorems all have to do with parallel lines. So for you to be able to use these theorems, you need to know that the lines are parallel. So for the first one, if you can find an F where the two arms of the F are known parallel lines, we can say that the angles below those arms are equal. So I can say E3 is equal to F2, and my reason for that, very important, I have to first write down my parallel lines and then corresponding angles. My second option is if I see an N or a Z. If I have that, and once again with the two legs of that N being parallel, I can say that the two angles on the inside of those legs or arms are equal. So in this case, I can say that angle E4 is equal to angle F1. And once again, my reason, I have to mention my parallel lines and then alternating or alternate angles. The last option is then when I want to use the U. And once again, for the U, those two arms have to be parallel. But in my U, I can now not say that the angles are equal, but I can say that the two interior angles add up to 180 degrees. So angle E3 plus angle F1 will be 180 degrees. And once again, I start by mentioning my two parallel lines and then co-interior angles. My next group of theorems have to do with triangles. First one is that we know that the three interior angles of a triangle all add up to 180 degrees. So A plus B plus C is 180 degrees, and my reason for that, interior angles of a triangle. Next, I can say that if I have an exterior angle to a triangle, that angle will be the same as the two opposite interior angles added up. So angle C will be the same as A plus B, and my reason for that is now exterior angle of a triangle. Next up, I have my equilateral triangle, where I know that all the sides of the triangle are the same length. From that, I can then say that the angles are all the same size, and they have to be 60 degrees to still add up to 180 degrees. So I can say that angle A is equal to angle B, which is equal to angle C, and they are all 60 degrees. My reason, it is an equilateral triangle. Then we have an isosceles triangle. Now in our isosceles triangle, two of the sides are equal in length. So when we know those two sides are equal in length, we can say that angle B is equal to angle C. Our reason for that, they are angles opposite equal sides. But here it can also work the other way around. If we knew that the two angles are the same size, we can say that side AB will be the same length as side AC, and this time my reason will be they are sides opposite equal angles. And then lastly, we have our 90-degree triangle, and here we're going to use the theorem of Pythagoras to say that AC squared is AB squared plus BC squared, and of course my reason, theorem of Pythagoras. In our next video, we'll focus on triangles.